So from this congruency statement, you can figure out which angles of those two trapezoids are congruent by matching up the first letter of one half of the statement with the first letter of the other half of the statement. So here the letters are in the right color, but a lot of times they'll just be black. So here, angle A is going to be congruent to angle E, and you can go ahead and mark that on the diagram too so you can see it. So here, angle A of this trapezoid is congruent to angle E, which means that they have the same measure in degrees, right? And the same thing happens then with angle B. So angle B then, the second one in order of that left side is congruent to the second one on the right side. So angle B would then be congruent to angle F, and you can go ahead and mark that. And remember, you can't use the same marking. If I use one tick mark here to mark that this angle is congruent to that, you can't use one again, or else you'd be saying that those angles are all the same. Yep? Yep, you can have 4 tick marks. So when we get to angle D, then I'll mark that one 4 times to show that that one is congruent to angle H. It's going to be. So here, B is congruent to F, 2 tick marks. All right, so what would angle C be congruent to? G. Does everyone see that here? You can connect third one with the third one. So here we're going to have angle C is congruent with 3 tick marks to angle G. All right, and then like we said, you're allowed to use 4 tick marks to show that angle D then is congruent to angle H. So now what about the sides? If we want to know what sides are congruent, how does our congruency statement help with that? So what would you guys guess is congruent to segment AB? EF. So again, order is very important. All you have to do is look. We want to know what's congruent to AB. Go ahead and look at that congruency statement and see what matches up with AB. So here we have AB, the first and the second terms of this congruency statement, and we match it up with those first 2 terms of the other part of the congruency statement. So here we have AB is congruent to EF. And then again, you can mark that on the diagram, keep track of what's congruent to what. So AB is going to be congruent to EF. Okay? So what would be congruent to segment BC? FG. Does everyone get FG? Everyone see where that's coming from? Now we're looking at these middle terms. So BC would be congruent to the other 2 middle terms, which in this case are F and G. And then we can mark those up. Again, you want to use not 1 tick mark, but 2 or 3. Just make it different from the other ones that you've used. So BC is congruent to FG. And then again, you're allowed to use 4 tick marks once you get to the end if you're marking that that's the 4th pair of congruent sides. Good. Any questions so far? Making sense? Congruency statements used to determine congruent angles and congruent lines. Good. All right, so here we have a congruency statement that this triangle ABC is congruent to this triangle FED. And we're looking for the measure of angle D. So we're looking to find this measure right here. So how many degrees are there in a triangle? 180. Okay. Do you guys know why there's 180 degrees in a triangle? Each side adds up to 180 degrees. Yep, each angle adds up to 180 degrees. So it's just like a mathematician. One they decided that triangles have 180 degrees. There's actually reasoning behind it. So if you look at this triangle over here, it's a right triangle. Looks pretty right. But if you take off all of these angles on the triangle, and if you put them on a straight line, match them up just like this, Then do you see how the bottoms of them make this straight line? And how many degrees are there in a straight line? Louder? Yep, and so that's why the triangle sum theorem states that triangles always sum to 180 degrees. So it's not just a made-up number that a mathematician decided, oh, we're just going to decide that all triangles add to 180 degrees, and that the angles in all triangles add to 180 degrees, but there's actually a reason behind it. So here, we're given that these two angles B is 30 degrees and angle A is 75 degrees. And we know that the triangle is going to sum to 180 degrees. And we want to solve for angle C. Why? Why do we want to solve for angle C right now? Huh? Yep. And it's because what angle are we trying to find the measure of? No? D. And what is D congruent to? Yep. So if we solve for angle C, then we know that C is congruent to D. So once we have the measure of angle C, then we will have the measure of angle D. Okay? So using that triangle sum theorem, we know that the measure of angle A plus the measure of angle B plus the measure of angle C is going to equal 180 degrees. So now we want to fill in the information that we have. So what's the measure of angle A? Good. 75 degrees. What's the measure of angle B? 30. And we're looking to find the measure of angle C, so we're going to go ahead and call that x. And we know that that is equal to 180 degrees. So now let's combine. Now 75 plus 30. Yep, 105 plus x is equal to 180. Next step. Yep, so 180 minus 105 is what? Good. So now what's our value of x is really what the measure of angle C is. So now we can say the measure of angle C is equal to 75 degrees. And then from this congruency statement, we can mark and we can see that the measure of angle C is congruent to the measure of angle D, which is what we're looking for. So these two are congruent. So since the measure of angle C is congruent to measure of angle D, therefore 75 degrees is what the measure is for angle D. Does that make sense to everyone? Any questions? Is it good? Okay. All right, so let's work through one of these now. So it's not a triangle this time. It's again a trapezoid. And this time we want to look at what the corresponding congruent angles are as well as the sides. So you want to look at that congruency statement. Let's blow it up a little bit. So we have H, I, J, K is congruent to L, M, N, O. All right, so first it wants to know what segment is congruent to segment HI. That's a good question. So is it LM or ML? How do you decide? Oh, you're looking at the diagram here? So I think first you want to try to look at the congruency statement because the diagram can get a little bit confusing until you have more marked off, trying to know what exactly is congruent to what. So it's wanting to know what's congruent to HI here. So if you mark here, it's like, oh, it wants to know what's congruent to those left two H and I. So what do you look for on the right side? On the right side then? What? Yep. Now, you asked earlier, is it LM or ML? How do you know if it's LM or ML? Because remember, the order is important. Yep. So you want to keep going in that order, and then you can go and mark on the diagram so that HI then you know is congruent to LM. And now, if you want to reference the diagram on some of the other ones, it's easier to keep what you already have marked is congruent to what. So HI is congruent to LM. All right, so let's look at IJ. What's congruent to IJ? M and N. So those are the middle two terms we're looking at. So the middles. Good. All right, how about JK? Huh? Santana? NO. Everyone see that? He's looking at the last two terms here are going to be congruent to the last two terms on the other side of the congruency statement. So NO. And then how about KH? OL. Does everyone see that? It is. It's a little trickier. They're not right next to each other, but they're still congruent to one another. If you look at that, the last term and the first term would still then be congruent to the last term and the first term on the other side. So OL. So KH, that would look like over here that KH is congruent to OL. And now you're starting to see as you add those tick marks and stuff how those two are congruent after all. All right. So what angle would be congruent to angle H? Good. So angle L. So H here, congruent to L. How about angle I? M. Right, angle J. Let's hear from someone who hasn't participated yet. Good. Angle J is congruent to what'd you say? Yeah. Does everyone see how I got that? Making sense to everyone? And finally, what's angle N congruent to? Good. All right, so now that we've worked on what is congruent in triangles, given a congruency statement, so what you guys are going to be doing with proofs is that, you're not going to be given a congruency statement, but rather you're going to be trying to prove that two figures are congruent. And so in order to find triangles that are congruent, congruent triangles have 3 congruent sides and 3 congruent angles. So it's just like what we worked with, finding the congruent sides and congruent angles, but in proofs you're not going to be given that all of them are congruent, and instead you're going to have to work with different properties that you know and prove that the triangles are congruent. So the blanks here are congruent triangles have 3 congruent sides and 3 congruent angles. Would it be okay, would the triangles be congruent if they have 2 congruent sides or 2 congruent angles? Would they still be congruent? Yeah? But what did we say that congruent triangles have to be? Yeah, because we said congruent triangles have to be the exact same. They have to have exactly 3 congruent sets of sides and exactly 3 sets of congruent angles. So that's really important when you're proving triangles congruent, is that in the proof you're going to have to show that all of the angles are congruent and all of the sides are congruent. All right, a review of what you guys have done in the past. So we're looking at these angles here. So angle BCA and angle DCE. So BCA is here, and DCE is here. So what is the term that references these 2 angles? What are these 2 angles called? I heard it. Yeah, those are called vertical angles. So you guys have worked with those in the past. I know you reviewed them again last week. So angle BCA and angle DCE are vertical. Are called vertical angles. And what does it mean about the measures of those 2 angles if they're vertical angles? Perfect. They're congruent. They have the same measure in degrees. Okay? So can everyone pull out your proof progression sheets that you guys got last week? I know you've gone through a couple of them. Is that sheet of paper with all the squares, blank squares? angles into our proof progression sheet. Reminder, you're going to be able to use these on quizzes and tests and homework. So make sure that you get this down because it's going to act as a good safety net for you guys. So that when you're working on proofs, you remember which properties that you can use to prove that things are congruent. Okay? So there you have a diagram of vertical angles. So here's your statement side, and here's your reasoning side of the proof. If you're given a diagram like this, you can mark these two angles and label them as vertical angles. And so what's new about this, because you guys know that those are vertical angles, what's new is transitioning into using these in proofs. So if you guys were given, if you guys identify that there's vertical angles, how you can use that then is in a proof is that you can say that the measure of angle ABC is congruent to the measure of angle XBY. So the measure of angle ABC is congruent to the measure of angle XBY. That would be your statement that you'd put in the proof. But remember, in proofs, you're not allowed to just make a statement. That's why we have those key tables. You have to have a reason. Maybe you're able to see that as well. So your reasoning would be that vertical angles are congruent. Yep. You would, if this is not a problem, so in an actual proof you'd be given a problem and you'd start working with the information that they've given you. But for right now we're saying that you've reached a point in the proof where you know that you're going to use the vertical angles, and this is what you would put, that those are vertical angles, and you know that they're congruent because you know that vertical angles are congruent. Okay? Everyone get that down? Good. All right, last thing before we do an activity is the third angles theorem. So this really ties back into that triangle sum theorem, where triangle sum is 180 degrees. Because it really makes a lot of sense when you think about it, that if you're given two triangles and they tell you that two of the sets of angles are congruent to one another, and then the third set of angles is also going to be congruent. So the third angles theorem says that if angle A is congruent to angle D, as you can see here, and angle B is congruent to angle E, seen here, then by process of elimination, angle C is then going to be congruent to angle F. Does that theorem make sense to everyone? It works out with, they have to sum to 180 degrees, so two of the angles are the exact same, then what's going to be left is going to be equal to. No. All right, so now we're going to do partner races. And so you guys kind of got used to how to do them today with the opening activity. Now you're going to look at this sheet. So you're not going to need this statement and reasoning table anymore because now we are working on what's congruent to what. So all you're going to need is this one. Yeah. Okay? Yeah. And so, not on your proof sheet, just in your notes. Okay, so in this activity, you guys are going to work in with the person next to you. I gave you guys sets of cards. You're going to first, are you good? Are you good here? Yeah. You're going to first work through the purple one, okay? And the problem that you're looking at is the first one that I set up for you in the paper plate. Okay, so all you have to look at right now is the purple set of cards and this congruency chart. And you and your partner are going to work together on matching up things from the diagram and putting them in here. You have to get my approval once you've gone through and you have all your purple cards matched up with one another. Raise your hand, I'll come around and check. And then you're allowed to move on to your second problem. Your second problem is either going to be salmon, blue or green. Just depends, they're different versions. And then once you're done with that one, raise your hand, I'll come around and check, make sure that you guys have everything right, and then we can move on to the third problem. And it is a race. Whoever finishes first or gets the farthest in the time that we have wins. Okay? What? No, but I have to hold you guys if you guys have questions. And to make it easier so you guys can see, if you look at your purple cards and all the cards, they have either a question mark or a star on them. So if it has a question mark, that means it's going to go on to the left side of your chart. And if it has a star, it's going to go on to the right side. So then you can keep track of what's a statement or what's a reasoning and a proof. But in this case, it's concurrency. Okay, so it's purple, and then you look for your second color, which is either going to be salmon, blue, or green. And then your third one's going to be pink. Okay? Work with your partners. we have another group on their last set here. Yes, look, you get checked. Looks good. You guys can move on to your second one, which for you guys is green. Looks good. You guys can try your next one. Nice job. Good job. If you guys want to go around and help other groups, you can. If you want to act as mediators.
You guys see that?
right, guys, that's all the time we have for this today. Wrap up the thought you're on. I'll give you guys about 20 seconds. We're gonna pull it back together. They were the first ones to finish. Go ahead and click on partner races. Just tap it. They were the ultimate champions, but all of you guys did a good job today. You guys can sit back down. All right, it's the last couple minutes. Let's recap what we did today. Okay, settle down, settle down. You guys have a couple minutes left. All right, so what are congruency statements used for? What do we get from congruency statements? What do we use them to find? Congruency between what? Angles and what? What else did we look at today? It's a congruency of angles and the congruency of not trapezoids, sides. So we're using congruency statements to find not only what figures are congruent, but what angles and sides are congruent to one another. So then in the definition of congruent triangles, exactly how many sides need to be congruent? Brian, how many sides need to be congruent? Huh? 3? Yeah. And how many angles need to be congruent? All of them, which if for triangles would be 3, but for trapezoids and things like that, it would be 4. So no less than 3 for triangles. It has to be all 3. Okay. So here's your homework. Page 221 was it 4? 8, 20, 21, 30. Okay. And I brought in snacks for everyone, not only the winners. Everyone can get candy.
I know